Awesome. Are we ready to get started? All right. Can y'all hear me? Awesome. I think we're going to go ahead and get started. Thank you guys so much for coming today. This is our demo day. We have Adam Gordon today, and he's going to be demonstrating milling lumber. He's a really valued member here at Asmbly, and he's been a member here for several years, so we're super excited.
Thank you.
Thanks.
Hey, everyone. Hey, all right, you want to go to the slides? I got a few slides to start, and then we're going to do some demonstration, and then I have more slides afterwards. So, lots of information. Try to just info dump on you everything I know. One moment. All right. We're talking about milling lumber today. I'm going to go to the next slide. All right, yeah, brief outline. I'm going to do an introduction, talk a little bit about safety, then talk about different methods of milling, and that's where I'll do a bit of a demo. Then afterwards, we'll talk about sort of the things you might not know if you're just getting into woodworking, like purchasing your lumber and planning your milling, and some tips and tricks I have for you. And then feel free to ask questions at the end. Go to the next slide. So a bit about me. I'm Adam. I grew up in Dallas, and I've been in Austin since 2016. I did biomedical engineering at UT, and I'm an MES engineer in my day job, where I basically just, it's kind of like software engineering. I help automate pharma factories and things like that. But I mainly identify as a maker, and I have lots of different interests in making. I do woodworking mostly, but I also do leatherworking, sewing, stained glass, 3D printing, robotics. And then aside from that, I do sports like triathlon and golf, and I like photography. So basically, talk to me about anything and I'll be interested. Next slide, you'll see some of my past projects. Yeah, you can basically make one of everything. I don't like to make anything twice, and just like to try new things and design stuff. You can see some leather and some robotics, but mostly wood. And you know, all of these projects basically started with milling my lumber, except for maybe some of the plywood ones. So it's an important skill, and if you're just getting into woodworking, or even if you're a pro, you gotta practice it and make sure that you're you know, up to speed. Next slide. All right, what is milling? Basically, milling is making your lumber that comes from the lumber yard rough and bent and warped into something flat, straight, and square that you can use in your projects. Again, it's super important. It helps you get accurate measurements, helps your glue ups be better. If you're making a panel, you don't want gaps like you see in these photos. It also just helps it look better. If you had something rough like this and you just wanted to use it straight from the factory and then sand it, it's going to take forever. So just milling is a good first step to get that face nice and looking good. It also gets better project outcomes and ensures less frustration. If you you know, are deep into your project and one of your boards ends up warped, and you figure out you didn't mill it, or you didn't mill it well enough, then you get frustrated. You might want to glue up a panel, and like you have to mill a board a little thinner than the others, and then you get like waviness and gaps and things like that. So milling is an important skill to have, and just ensures less frustration and saves time and money in the long run too. Next. Yeah, safety, obviously super important in the shop. Woodworking is dangerous, and the jointer is one of the scariest machines in here. It will not hesitate to kill you or hurt you if you let it, so don't let it. Just make sure you don't have any loose hair or clothing, any jewelry. Wear eye and ear protection at all times, except for maybe today. And always use push sticks and blocks. Always use dust collection. I think today we're not going to use it because we're not going to be using it too much. We're going to clean up afterwards, but if you're in the shop, make sure that dust collector is on, because that's been a problem recently. Never remove the safety equipment. So this jointer has a guard here, and there are some instances where you might want to remove it if you needed to do like a rabbet on the edge or something like that, but in most instances when you're just milling your raw lumber, you always want it to be there. Same with the table saw. We're going to be using that later, and the riving knife on there you never want to remove. And just the most important thing is think before you cut. I always like to visualize my cuts and just make sure I know like where my body's going to be and where you know the blade is going to be, and just don't put your hands near a spinning blade. Next. All right, we'll talk a bit about different methods of milling. Move on. So the traditional way of milling your lumber is just with hand tools. You use hand planes, spoke shaves, sort of, saws and chisels and things like that to get your lumber flat. We're not going to be really talking about that today because, first of all, I don't really do that much, but second of all, you can write a whole entire book on that. And yeah, if you're interested in that, I would recommend watching some YouTube videos or something like that. Going to, I think, Austin Furniture School or something like that has a class on hand tooling, so if you're interested, go there. Then there's router jigs and CNC, which is useful for large boards or uneven boards or slabs, basically things that wouldn't fit on the planer or the jointer. It's also useful for end grain, like cutting boards, because it's not usually recommended to feed cutting boards, or end grain rather, through the planer, because it has a tendency to chip out, and if the glue's not great, it could explode in the planer and ruin your project and be dangerous. So that's what that's useful for. We'll talk a little bit about resawing, and we have a nice big resaw saw here, so that's a nice amenity that we have that a lot of people don't take advantage of. Your machine tools, the main workflow for milling is going to be your jointer, your planer, and your table saw. So we'll talk about each of those, and then we'll go a bit into planer sleds and other methods that people might not be aware of as well. So first, briefly, we'll talk about, go ahead, James. Yeah, we'll talk about routers, sleds, and jigs. I briefly talked about them already, but basically they're essentially a manual CNC machine, an XY gantry system that has a router on top of it that is useful for moving the router in a plane over your material. It's good for irregular material and oversized material, like that slab you see there. So obviously you couldn't feed that through the jointer, so if you want to get that flat, you're either going to need to use I guess you could use hand tools, but what most people might use is a router jig like that, or a nice big CNC like ours. Uses one of these big flattening bits. Some of them you'll see are mainly for spoil boards, and if you were into wanting to use the CNC, you're going to need to take the CNC class, and James might talk more about that there. But you want to make sure you are getting a bit, if you're using these, that is good for hardwood. And yeah, I'm not going to explain router sleds, but it's definitely an option. Because that's an important one, and I've used it before. And yeah, we'll go on to the next slide. So resawing is a method of splitting one board into several thinner boards, and similar to ripping, but you're splitting the thickness rather than the width of the board. It's usually done on the bandsaw. It's possible to do it on the table saw as well if you have something not too wide, but usually you're splitting a board that's 10 inches wide, and you can't do that on the table saw, so you're going to do that on the bandsaw. So you'll take a board like this and split it down the middle like this, and you'll get two boards that are about half the thickness. And that's useful if you have valuable material that you don't want to waste. If you have a 2-inch wide board and you need two 1-inch wide boards, you can't just do that on the planer and the jointer, because you're just going to end up with one board and sawdust. So you're going to need to do that on the bandsaw. Here's an example of some resawn material. This was I think a 3/4 inch walnut board or something that I basically made into thin veneers on the bandsaw here. So it's useful for conserving material. It's also useful for making book-matched panels. Basically, if you have one board and you open it up like this, you can get cool designs like you see. I don't know if the slides are there, but on the bottom of the slides. And it reduces waste, and it's useful for oversized wood as well if it doesn't fit. Well, oversized is in if you have a 2-inch board and you want a 1-inch board. And it's also useful for logs and things like that. If you had a log that you wanted to split into more useful boards or trays or something like that, you can do that on the bandsaw. And we're not going to be demonstrating resawing today, but if you want more information, feel free to talk to me afterwards or look up videos and things like that. So the jointer is sort of the bulk of the milling workflow. It's this tool right here. If you don't know what a jointer is, it's used to flatten, smooth, and square one side and one edge of a board before. It's basically the first and the second step in the milling process. So it basically consists of an in-feed table and an out-feed table, and then a blade here that spins underneath the material. And the out-feed table is fixed and doesn't change in height, but the in-feed table can lower beyond the blade. So if you look on the slides again, you might be able to see that the in-feed table is lower, and basically as you pass the wood over the material, it takes a little bit off and comes over to the out-feed table, and everything's flat. So each time, if you have a bowed board through there, each time you go through, a little bit of material will be removed until the entire bottom is flat. So that's the first step in the milling process, and then the second step usually is to take that flat side you just made. If I just made the bottom of this flat, you take that and ride it up against the fence here and mill one edge that's going to be perfectly 90 degrees square to it and also flat. It is good for correcting things like warp, bow, twist, any kind of wood abnormality. And let me see if I have any tips and tricks that I want to say before I go on to it. Usually when you, I think this is the board I wanted to use. I'm trying to find a good board that has a little bit of warp to show you. Okay, yeah. So usually, if you have a bowed board, I mean, most boards that are going to come from the lumber yard are not perfectly flat. So you're going to have some rock in there, some twists maybe. If you look down the length of the board, you might see that it bows out. Or I don't know how well you can see that, but down the edge of the board, there's a bow in the edge. So usually, when you start on a face, you want to start with the concave side down, because that way it doesn't rock when you're going through, and if it rocks when you're going through, then you end up with a wonky board. So you start with the concave, well, this is a concave side up, and you don't want that when you're going through. So you start with it down, and then you push it through. And another important tip is you don't want to apply pressure in the middle, because if you are basically using a push block when you're pushing it through and you apply pressure in the middle, it's going to still joint that surface underneath, and then you let go of the pressure and it's going to go back to bowed. So usually when I mill my lumber, I like these push blocks, and I just apply pressure at the ends and just kind of feed it through. It really doesn't need much pressure, especially if you have nice lubricated surfaces. And then another important tip is to ensure that the fence is square. I think right now the fence is not square. Maybe you can see that. If you zoom in, it's not square at all. So when we get to the demo, I'm going to be squaring that up just to show you how you might want to check that every time you mill a board.
Hey Adam, quick question.
Yeah,
How
go
much
ahead.
pressure are you putting on the board?
Really not much at all. I mean, if it's a large board, you might need pressure just to have friction to push it through. But you really don't want to apply pressure, especially to the center. On the edges, especially with one of these push blocks, I like these because they have these little nubs on the back. And if you latch that on the back of your board, you kind of just apply lateral pressure instead of downward pressure. And then this one is mainly just to keep it seated on the bed, but not really to push it into the blade or anything like that. So you kind of just a nice firm pressure, but not pushing it deep into the table. You're not putting your weight on it or anything.
Thank you.
All right. Well, I might come back and if I have any more tips afterwards, but I'll try and demonstrate jointing a face right now. So things with the jointer on-off buttons here. Here's your depth adjustment. Usually when you're milling the face of a board, especially if it's a wider board, this has a capacity of, I think, 10 inches or 12 inches maybe. Excuse me. So if it's a wider board, you want to take smaller depth of cut because it just puts more pressure on the machine and you might end up with chatter and things like that if you take too much of a depth of cut. So when I'm milling the face of a board, I like to usually only take maybe a 1/16 off. And usually it's set around there anyway. So I think actually on our machine we say 1/16 max depth of cut. Sometimes you can take more than that off if you're using if you're milling the edge because there's just not much material there. But if you're milling the face of the board, a 1/16 is a good starting point. And if your board has any rock in it, this one doesn't really have rock, it's kind of just got some bow. If you push on like the corners of the wood, you can kind of see if it's going to rock on 2 of those corners. I think this one maybe had a bit. Let's see. Yeah, you can kind of see it's rocking a little bit. So if it does have that, it's best to eliminate that rock. If you're going to put pressure here, like right in the center, you might sort of like vary your pressure and you might rock while you're going through the cut. So usually I like to kind of put it on one end just so it mills only one end and it doesn't rock while you're going through the cut. So maybe we'll use this just to show that. So you're going to turn on the jointer, push it through, and then, be mindful of your body. I'll show you. Actually, first things first. One important thing that I skipped over when you're using the jointer is you want to mark your face to ensure that you're taking off what you expect to take off. So usually we have some chalk here, or you can use some pencil, but you just mark your face with some chalk, and each time through you can see how much you've taken off. So now that we've marked it, let's start the jointer, put it on the edges, ride it up against the fence, and just kind of push it through. Push it all the way through so that the guard closes before you let go of anything, just so you know where your hands are. And you can see it's removed almost all, but there's a little high point here, so it hasn't removed the chalk here. And that rock should be pretty much eliminated. Maybe it needs one more pass through, but certainly a lot less than it used to be. And yeah, there's your jointing. I'll do one more pass to get rid of that chalk. And also, another thing I like to do, I don't know how important it is, but if there's a lot of sawdust on the table, you don't want to like ride on that sawdust because it might create a little high point there. So I usually just like to make sure your surface is clear before you put it down. Yeah, so now we got a perfectly smooth surface with no chalk marks and no rock, no bow, nothing. So you got one face jointed. And then you can tell it looks a lot better than the rough lumber as well. So next step, any questions about jointing a face? Yeah?
Does the depth of cut affect the surface finish you get much?
It can if it's too deep. It depends on the type of wood. Like it won't affect it.
Adam, will you repeat the question?
Oh yeah, sorry. Yes, does the depth of cut affect the surface finish? It certainly can. If your final pass is, 1/8 of an inch deep on some hard lumber, it might have some tear out and things like that. If you are milling a board, usually you're going to take more than one pass. So if you pass it through the first time and it's too deep and you find that there's bad surface finish or tear out, you can decrease the depth of cut, especially for the last pass. If it's your final pass through, you might want to decrease the depth of cut. One thing that does affect or could affect the surface finish is the grain direction, which I didn't talk about yet. I think I have that in my slides later. But in your boards, usually there's a grain direction. It's hard to see in this one, but the grain kind of runs down and back. And I didn't check that before my cut, but that's where you want your grain to run down and back. So if you have your grain basically running like this, you want the blade to sort of, it spins this way, so it's going to come and like tear out like this. Whereas if you had it like this and it was up and forward, I think. Basically, if you were coming the opposite direction and it was tearing like this, then it could tear out more and basically rip the grains out, and that's where you get tear out on the jointer. So if you're getting bad surface, it's honestly something that I don't think about too much because I generally end up with better surface finish, but if you find something that has bad surface finish and you're sort of questioning why, you might want to check the grain direction. So yeah, I would say yes, smaller depth of cut probably will produce better surface finish, but it's not something I think about too much because usually, a 1/16 of an inch is fine. Any others? Yeah, Jordan?
If you have a different hardness in your boards, do you have to move at a different speed?
Yes, maybe. Oh, sorry. If you have a different hardness in your board, do you have to move it at a different speed? I would say yes and no, because the board kind of dictates the speed of the cut. You kind of just want to let the cutter do its cutting, and you don't want to force it through faster than it feels like it's feeding, but you also don't want to go too slow. So you kind of just push with the same pressure with every board, and it's going to go through at different speeds depending on what the wood is. That's really noticeable in like the table saw or something. If you cut something like hard maple, it's going to really not want to be cut, and it's going to be slow and it might burn, and that's one of the reasons that hard maple is a bit harder to work with than something like walnut, which is super workable and cuts like butter. So your speed will vary, but it's not really a function of how hard you push necessarily. It's more of a function of the wood.
Can you show us the final pass on that one?
Yeah, this. Yeah. The final pass, yeah, nice. This is Paduke, so you got some nice orange color here as compared to a little bit rougher, darker color when it's been oxidized some more. Yeah, nice and flat. Another thing I like to do before I move on to jointing my edge is mark your jointed face. Sometimes, like with this, it's easy to tell which one, but with some it's not. So usually you mark it, like the general woodworker's sign is like a little swirly like that. I don't know why, but that's what I've seen online, so that's generally what I tend to do. Your jointed face, you mark with one of those or a couple of those, and your edge joint, when you end up doing it, you're gonna mark with like a little dashed arrow that points to the jointed face, but I'll do that when I get to it. So next we're going to joint the edge of the board. And the most important thing that you got to think about here is if the fence is 90 degrees. Because if it's not, you're riding the fence, you're going to end up with an edge that's not 90 degrees too. So basically before I joint any board that I'm using the fence for, I'll make sure it's 90 degrees because often it's not if someone applied too much pressure. So our little fence stop thing is there, so loosen it, and then it really doesn't apply, or doesn't require too much pressure to change the fence angle. Maybe you can see it better over here. Yeah, so you kind of just apply a little pressure. It's a little hard to adjust, to be honest, until you can't really see any light through there. Yeah, there we go. Yeah, so that's perfectly level. I can't see any light on the ruler. I know it's hard to see, but you just got to trust me. And then you lock it down and make sure. And then once you lock it down, it's also possible that introduced some jiggling to it. So usually after I lock it down, I like to check it as well. We're still good. So yeah. One of the more important parts of milling is just making sure that the alignment tools that you're using are actually square, because if they're not, they're just going to introduce the not square part to the board. Yeah, so when you're jointing the edge, generally we say always use push blocks. I think if your hands are far enough away from the cutter, I generally just use my hands for edge jointing. But if I had a board that was thin like this, I probably wouldn't want my hands, right here on the jointer and things like that. So just be mindful of where your hands are, and if they're 6 inches away or so, I'm not too worried about it. But if they're closer than that, you're going to want to use a push block up against the fence and maybe a push block on top as well, and just kind of push it through. Edge jointing is easy because you really only need pressure on the fence, not really down. So you kind of just go like that. With this one, I'm just going to use my fingers, push it up against the fence, and then just make sure you're not on the bottom edge or anything like that. So yeah, just make sure that you're actually pushed up against the fence. You're not at an angle like that or something. And let's go. Actually, wait, before I start, it's useful to check which side is concave and which is convex, if there is one. So in this case, there's really not too much of a bow on that side. This side, so this board doesn't really exhibit it that much, but this one, for example, has some major, I think that's called kink or something in the board. So if you were jointing this one, you want to make sure this edge is or you're jointing this edge first instead of this one. This one's, yeah, there's some rock, so something to be mindful of. This one, it doesn't seem to matter too much, so we're just going to choose this one. But, whoops. All right, let's joint. Make sure we're up against the fence. push it through. See, it wasn't too, I don't know how well you can hear me when that's running. You can see one pass through, took off some material, but there's a few low spots here. So we're going to take another pass. Oh yeah, let me mark it with chalk so we can see a little better. I think this pass will probably take it all off, so I'll just be able to see if there's any left. So there you go. All the chalk is gone. There's a few imperfections in the wood, but it's not warpage or anything like that. There's just a little hole there. But you can check its flatness on this table, and yeah. It has a little rock back and forth because it's thin, but you know, no bow or flex or anything like that. So now we're gonna mark this jointed face and this jointed edge so you can remember. Again, this one is pretty obvious because this is still a rough edge, but certain boards that you'll have will have a smooth edge on either side that just might not be 90 degrees, so it can be hard to tell if you don't mark which edge. And yeah, that's basically the jointer. A few things to mention as well. These boards are relatively short, so they're easy to joint, but if you have a really long board, it can be difficult, especially if it has a large bow in it, so it's useful to either extend this work rest, if that's useful to you, or to use one of these rolling mounts if you have something really long and you want to set the height to be, you know, pretty much level with everything else. I'm not being super exact here, but you want to try and be as exact as possible, because if it's too low, it'll ride too low and then it might like sort of rock as you go through the cut. So you just want to make sure that this is going to be the same height as that, and if you have a level or a square or something to check that, it's useful. Really long boards are much more difficult to joint than short boards. Things that are on the bed the whole time are much easier because you don't get any of this edge deflection. If you have a bowed board and is riding the edge, you know, it starts off here, but as you push it through the cut, this side is actually raising, so it's pushing it more into the jointer. So it can be difficult to mill longboards. If you need to mill a longboard, if you're making a bed, for example, and you need a long section for the side pieces, you know, it's just something you got to work around. Use these tool rests if you have an in-feed table or an out-feed table, which I don't know. We have a couple, yeah, like maybe that thing is a little more useful for supporting your wood. Or you can, these MFT tables aren't the right height, so you can't use those. But, you know, use whatever you can to support your wood on the way through the cut. A few of these is helpful too, because if you just have one on the end, you know, it's still going to do the same thing, where as it rides through, it still is going to change its angle a little bit. So I like to use 2 or 3 of them if possible. But if you don't need to mill a longboard, if you have like, you know, say an 8-foot long board, but you're trying to make a cutting board, you could probably cut it into smaller sections on the chop saw first. And that's useful because if it's really bowed, first of all, the more you mill, the more material you're losing. So if it's really bowed and you try and mill an 8-foot long board, you might end up, if it starts as an inch, you might end up with a 1/4 inch, who knows. So if you can cut that into, you know, 16, 18-inch segments first, it's going to be easier to mill and you're going to save a lot of material. If your bow is extreme, sometimes when you're going through, it can get caught on the leading edge of this outfeed table. So if your bow is extreme, it's useful to either sand or chamfer this corner a little bit. Sometimes you might not know that you need to do that until it does get stuck. So usually if it gets stuck, you can just back it up and try to go through one more time, and that first joint sort of acts as a little chamfer that gets it over the top. But if you know that it's bowed, it might be useful to just chamfer this edge a little bit, just so it doesn't get caught there. Yeah, any other questions about jointing? All right, we'll move. Yeah, oh yeah. Yeah. There you go, that makes sense. Interesting, yeah. You can see it on the slide a bit more. Sorry, I keep forgetting. Yeah, he was saying that the little curly Q that you mark the jointed face with is apparently meant to be a cursive letter F for face. which is something I didn't know. I just thought it meant curly. Yeah, on this, oh yeah, we'll go to the planer. All right, so brief bits about the planer. It's that tool over there. A lot of people think that it flattens boards. It really doesn't. All it does is create an even thickness. So if you put a bowed board in, it's going to come out, an even thickness, but it's going to come out still bowed. So if you have something bowed and you want it to be flat, you really need to use the jointer. That being said, there's a couple methods that you can use to flatten on the planer, which I might talk about later. So take that with a grain of salt. But for the most part, the planer is used for thicknessing wood, not for flattening wood. You can see in the top right corner, there's a little picture too. Like the jointer creates a flat surface that's not necessarily parallel to the top. The planer will make that top face parallel to the flat face that you got on the jointer. It's the third step in the milling process, and just some small things. It does not flatten wood. You want to take generally small passes on this handle. I don't really know the distance, but usually I do a half-turn pass on most wood. If it's really wide, if it's as wide as the bed of the planer, I might do a quarter turn, especially on a finishing pass. But small passes are better. And then if you have, say, a 2-inch board, and you are required to have a 3/4 inch board, you probably don't want to plane off 1 1/4 inch. You certainly can, but a lot of times planing that much can release internal stresses in the woods and things like that. So even if you started off with a flat face on the jointer, if you take off, 70% of the thickness of the wood, it will end up bowing anyway. So if you have a really thick piece that you need to be really thin, it's better to resaw it first, get off as much as possible, and then go on to your jointing and planing after that. So yeah, I said over 50% thickness. That's kind of a made up number, but just if you're taking off too much thickness, it's better to resaw first than it is to take it all off through the planer. And yeah, the planer is actually one of the simpler tools in the shop. You kind of just feed it through. Not too much in terms of safety, so obviously don't stick your hands in there. But yeah, some things about the planer. In-feed table, out-feed table, here's your depth adjustment. So my depth, where I usually start, is this little black piece here, juts out a little bit below, so I'll put my piece there and run the table into it, and then I'll back it off for about 3 turns. I don't know how much I just did there, to be honest. 1, 2, 3. Yeah, I back it off 3 turns, and I think that's enough that it doesn't actually cut it at all. Wait, that's the wrong face. So yeah, when you pass it through, you want to make sure your jointed face is down on the bed, because that's the flatness reference that we're then going to plane the top face with. So let's do this. You're going to want to mark this one too, just to make sure you're taking off what you expect to take off. The depth is set, and yeah, we just turn it on and feed it through. Yeah, and it's too low, so it didn't cut anything. So then you kind of sneak up on it. You'll do a half turn. It feeds it through now, but it may cut high points if there are any, but there aren't any, so it didn't cut. And you do another half turn. And now it starts to cut. You can see, turn it off for a second. Yeah, so this board was already pretty flat to begin with, so there's a little bit of roughness on the edge, and it seems like a little low point here that it didn't cut, but for the most part, it's pretty flat already. So we'll do another maybe quarter turn, see if we can get all of it off. And we were able to. So, yeah, it's useful to sneak up on your cut like that. If you just start with too deep of a cut, your wood can sometimes get stuck. Especially, yeah, if you like run it up into here and just back it off like a quarter turn, that's probably like, I don't know, 30 seconds of an inch cut or something like that. And that can be too deep, especially if you have a wide board. So if it does get stuck in there, you can either apply a little pressure, but you don't want to force it through, Mostly you just back it off and try and restart. Oops. Yeah. And yeah, so we can check this side is the side that we jointed, and it's flat. No bow in there, and then this is the side that we planed. Maybe there's a little bit there. But for the most part, it's very flat as well. So there you go, that's the planer. Any questions about the planer? Yeah.
Not specifically about the planer, but you're doing this after like it's sat inside and moisture is kind of at a
Yeah, exactly. I'll talk a bit about some tips and tricks later. That's one of them. Oh, sorry. She asked, not specifically about the planer, but if I was doing this after it sat inside for a little bit and moisture has sort of equalized. Moisture is certainly an important consideration for woodworking. It changes everything. So it is something you want to do, let your wood acclimate in your shop, and I'll go over that in my tips and tricks later on.
Looks like we got another question.
I am, yeah. Good. This bit? Yeah, that's the next step. That's the table saw. I'll get to it.
One more question before you move on. If you're using a lot of materials on these tools, is it helpful to put anything on the bed?
Yeah, it can be. So if you're, she asked if you're using a lot of material, if you're planing, a big quantity of wood, is it helpful to put anything on the bed? It can be helpful. So these beds are just made of steel, and over time they can either rust a little bit or oxidize a little bit or just get a little bit frictiony. So it's helpful to lubricate them. If you find that you're having a lot of trouble pushing it on the surface, maybe you're applying too much pressure, first of all, but if that's not the case, the bed just might need to be lubricated. So I'm not sure if we have any around us right now. Yeah, he's grabbing some. There's some spray lubricant that we have here. It's in the steward's closet, so, oops, careful. So if you are not able to access it, you might need to ask a steward to use it. But if you are milling a lot of wood and you find that that's a common problem that you have, it might be useful to get some bed lubricant. This is Bostik Glide Coat, which is a silicone-based lubricant. But you can also use paste wax and things like that. If you do use it on our tools, just make sure that it's actually something that is recommended to be on a tool bed. But certainly a lubricated surface can help a lot. And the jointer, the planer is one thing that does help for if you find that your wood always gets stuck, even if it's not too deep of a cut. One of the reasons might be that the bed is not lubricated and that it's just sticking to the bed. So often a coat of Glide Coat or something like that on a clean bed will make it glide right through. Any others? Great. All right, table saw is the last step in the milling process, sort of. You might also have a step where you cut it to length. I wouldn't necessarily call that milling, but we'll call this the last step. And it's pretty simple. The table saw can be a scary tool for some people, but this is a pretty simple cut. Oops. Let me get some of this stuff off. I don't know. So I'll move it over on this side for now, but I don't think I'll cut on this side because I'm not used to it. But yeah, basically you just want to ride your jointed edge that you just made up against the fence and remove as little or as much material as you want, just to make sure that all of this rough edge comes off. So for your table saw, you want to raise the blade. Well, first of all, let's raise it all the way up, because one of the most important considerations on the table saw is to ensure that your blade is at 90 degrees, because that's what's going to ensure your next edge is square. So we have these little digital angle gauges here that you want to zero, usually either right in front of the blade or right next to the blade. The table should be flat, so it shouldn't matter, but it never is. So I know you guys can't see this that well, but I'm just zeroing this digital angle gauge, and then you stick it to the blade. Yeah, right now this blade is at 86 degrees, not 90. So if I were to cut now, I'd have one edge at 90 and one at 86. So then I'll change the angle. Whoops. Just sneak up on that 90 degree measurements. Oops. Overshot it. There we go. That's 90, and then maybe I'm traditional, but I don't like to trust those, so I like to check it with a square too. So just, again, I know you can't see this that well, but you're just ensuring your blade's at 90 and that you're not, in fact, I think that is a little off. There we go. Perfect. So yeah, make sure your blade's at 90. One of the most important things, especially on a shared tool like ours, you never know what the last person did. If they for some reason needed an 89-degree cut, it may look 90, but it's not. And then you're going to want to make sure that the blade, just for safety, isn't peaking up too high over the material. Usually I like to have it so that the top or the bottom of the little valleys in there are just over the material. But that can also be personal preference. And yeah, I'm going to move the fence back over because I'm more comfortable on that side, but you just push it through so that you cut that edge off. Oops. And then again, whichever side is down doesn't really matter at this point, because hopefully if you did the last two steps right, they should be parallel and both flat. So I'm just going to choose this side. Make it so that it's going to basically just cut only the edge off and maybe leave a little veneer, but maybe not. Should have turned on the saw already, but it's got to warm up a sec. Yeah.
Side that you put towards the fence.
The side towards the fence is going to be your jointed side. Yeah, good question. Yeah, make sure that your jointed edge rides up against the fence, because obviously that's what's going to transfer the same plane to the other side. And use your push sticks. I should have grabbed them earlier, but always be safe. I like to use these push sticks. And I'm going to turn on the saw. Usually start like this and just kind of. So yeah, you can see about how much I cut off was a pretty thin section. If you needed, a thinner board than this, you could certainly cut off more, but usually just when you're milling, you're going to cut off as little as possible, and then later on you can cut more. So yeah, this edge was the edge that I just cut, and you can see, it's hard to see anything, but hopefully I did it right. And now it's also flat. There's no rock in it. There is, just because it's thin again, but side to side there's no rock, and same with the side that we jointed earlier. So yeah, now you got a square board on all four edges, and you're ready to proceed to your next step. Yeah?
Now, why wouldn't you just plane both sides?
Good question, yes. Why wouldn't you just use the jointer on both edges, right? That's a good question. So if you did that, you might find that this edge could be, let's just draw it. If your board started out a little bit like this, like a little wonky like that, you're going to have this edge flat and 90 degrees, and you might have this edge 90 degrees to the board, but it's not going to be parallel to this edge. So really you need the table saw to ensure that this edge is parallel to this edge. Otherwise you're going to have two edges that are 90 degrees to the other plane, but they're not parallel to each other. And really you want, this face to be parallel to this face and this edge to be parallel to this edge. Good question. Anything else, Jordan?
So at this stage, if you were to purchase this board, what would the classification be? S4S?
What do you mean?
So,
You asked what the classification would be for this? Oh, I see. I think I got your question. So
yeah.
Her question was, at this stage, what would the classification or style of this board be? This is basically surfaced on four sides, which is a type of board that you can actually buy at the lumber store. They sell woods, they call it S4S, or surface four sides, basically just means that it's an even thickness and the edges are 90 degrees. But what it doesn't mean necessarily is that the board isn't warped, because a lot of times wood can move after it's milled too. So you buy an S4S board from the store assuming that it's going to be a straight board. And while it might be square, it might not be straight. So you just got to ensure that, you might look down the center, make sure it doesn't rock, and ensure that it's actually going to be straight. But yeah, this is surfaced on 4 sides. All right, so that's the general workflow. If you want to go back to the PowerPoint, I have actually a lot more slides. I might skip through some of them because the milling process is relatively short, but there's a lot of things to think about before and after milling. Where am I at? Oh, actually, before we move on to that stuff, there's one other thing I wanted to talk about. So you might ask, what if I have a board that's too wide to joint? If you have, like I said, we have a 10 or 12 inch jointer, but if you had a 13-inch wide board, you wouldn't necessarily be able to joint one face of it. Not to mention if you had a slab that was 15 inches wide or just something that was irregular that you didn't want to use on the jointer. One option you have is a planer sled. And if you go to the slide real quick, I'll talk about it. I think it's right after this. I think it's right after this. One more, yeah. So a planer sled, basically, I was talking earlier about how the planer doesn't flatten anything. It only transfers one flat face to the other. So if you had a board that was bowed, you obviously don't want to put that in because it's going to come out bowed. But you could use something like a planer sled, which is basically just a flat piece of something that's already flat. Usually we use MDF or something because usually it's pretty flat. And if you put your board on here and then feed it through the planer, then it will transfer the flat edge of the MDF to the top. So to use one of these, usually you want to have a piece of MDF. This one actually isn't, it's meant for the sander, not the planer, so this one actually doesn't fit through the planer, so I can't demonstrate it. But you're going to have something that will fit through the planer. You're going to put your board here, whichever side you want to plane. With this one, it doesn't actually matter as much, but usually I would put the concave side down as well. And then you're going to have a little backstop here that can basically just stop it from shooting off the back of the board. And you're going to use little shims or wedges underneath the high points. So for this, let's just pretend I was doing it this way. It had a little rock in it. You might want to push down here and put a little shim there and shim there. All the high points. Yeah, and then it doesn't really need it here. But now it's supported on all sides. It's not rocking or anything like that. And you're going to want to secure these down. Usually we use hot glue. So I don't know if we have a hot glue gun available right now, but useful to have. And you just hot glue the shims down and the board to the board down. And then once it's all secure, you can just feed this through the planer, and this will transfer the flat edge of here to the top of the board. And that basically acts as the first step in the milling process itself, and replaces the first step being the jointer with the first step being the planer sled. And then if it was a square board that you still wanted to square up, you could still joint the edge on the jointer and then plane the other side without the planer sled, referencing that top flat face you just made against the bottom of the planer bed. Yeah, go ahead, Jordan.
Could I use that same process on the wide belt sander?
You can. She asked, can I use that same process on the wide belt sander? Yeah, that's a good question. It's useful. You certainly can use that same process on the wide belt sander. It's similar to the planer in a lot of ways, actually, but in the way that if you put in something bowed, it will come out bowed. So if you use a planer sled, or I guess a wide belt sander sled in this case, you certainly can use it in the same way. And that's useful for, like I said earlier, end grain in the planer is not a really good idea because it can cause chip out on the edges, like you can see in this one, which I did feed through the planer. And if there's stresses in the wood or fractures or anything like that, then this just causes a lot more stress on the material and can cause it to explode or crack and things like that. So if you had a nice cutting board that you didn't want to have crack or explode, the planer is a bit too rough of a tool for it. So the wide belt sander is a good option for that, and a planer or a wide belt sander sled would be useful for that. All right. Any other questions about planer sleds? No? Cool. So now we'll just talk a little bit. I'll skip through some of these because I put too much information down, but feel free to ask me because I might have more. This is about choosing and purchasing lumber. If you're new to woodworking, things that might not be intuitive necessarily. Some species selection, hardwood versus softwood. It's interesting because that distinction actually doesn't have to do with the hardness of the wood necessarily. It has to do with the type of tree it comes from. So hardwood comes from deciduous trees, and softwood comes from coniferous trees. And in general, hardwood is harder than softwood. That's why it gets the name. But there are certain softwoods that are harder than certain hardwoods. So, don't necessarily just go by the name hardwood to know that it's hard. And in the category of hardwood, there's also different levels of hardness. Something like hard maple or ironwood or something is super dense and hard, whereas something like cherry, well, cherry is pretty dense too, but walnut's pretty not dense, and oak isn't too bad either. I'm not going to go through the styles of wood, but certain ones are good for different purposes too. If you're planning a project that's making end grain cutting boards, you want to make sure that you're not choosing a wood that has super open grain that whatever you're cutting on top can seep into. So something like oak is not really a good choice for cutting boards, whereas something like maple, which has super tight grains, might be a better choice. Outdoor furniture might need different woods if it needs to withstand the weather. Whether it's structural or cosmetic, you might choose something softer if it's cosmetic. If it's rarely handled versus if it's expected to be in a high wear environment, you might want it to be something harder. And you might choose wood based on its workability, like I had talked about. If you're not comfortable with working with super hard wood, maybe don't choose them. Appearance is honestly the main reason people choose woods, which is fine too, but there are just other factors to consider. Next slide. So this is something to consider too when you're deciding on what wood to purchase. Is basically when they cut a log down, there's many different ways to slice it into boards. The most common one and the cheapest option for you is going to be plain sawn, where they just slice it down the middle, and that leads to some interesting grain where you can sort of see those growth rings if you look at the picture. It's the least wasteful option, and therefore the cheapest. If you go to fine lumber, they're going to have their plain sawn wood as cheaper than their quarter and rift sawn wood. And speaking of quarter, it's basically similar to plain sawn, except they chop it into quarters first and then they plain saw it. So you're going to end up with a straighter grain that has maybe some figuring that you can see. It's a little more structural and less prone to warpage, but a little bit more expensive than plain sawn. And rift sawn is the most wasteful. They basically try and cut it perpendicular to the growth rings. So you're going to have the straightest grain and the least imperfections, but the most expensive. So it's not really available in all styles of wood. Honestly, the one I see it most often in is oak. So if you go to fine lumber, they sell plain sawn, quarter sawn, or rift sawn oak. And rift sawn is like $3 or $4 per board foot more than plain sawn oak is. So it's something to consider if you are purchasing lumber. The benefits, like I think plain sawn looks pretty cool, so does quarter sawn. Rift sawn's a little boring to me, but if you're making something structural or you want it to be super even, maybe you want to buy rift sawn. Go ahead. So some types. At the lumber store, you might find wood that's called S2S, which is surfaced on two sides. That's basically, they joint one side and they plane the other. I don't think they actually use a jointer in the planer. They probably have some crazy tools to do that, but basically it's guaranteed that it's an even thickness. Again, it might be warped still, but there's not going to be many divots or pockets or anything like that in the wood. And the edges on S2S are still rough. You still need a joint and table saw those. S4S is, like we had talked about, what this board is right now. It's an even thickness and all the edges are 90 degrees. Again, it might not be unwarped, so you just got to check that. Like I mentioned, warps. It warps even after it's milled, so yeah. What you might end up milling most often is raw lumber. And when you go to a store like Woodcraft or Fine Lumber or wherever, it comes in random widths and lengths. The thicknesses are the one standardized dimension, and they measure it in terms of quarter inches. So you'll see 4/4, which is pronounced as 4/4, and that means 1 inch. It's 4/4 of an inch. So you'll see walnut 4/4, walnut 6/4, which is a 1.5 inches, or walnut 8/4. So yeah, if you're looking for 1.5 inch boards, look for 6/4, 6/4. And prices will vary, week to week. So if you're interested in the prices, you can call ahead. Thicker boards like 8/4 are usually more expensive per board foot than thinner boards are. So, something to consider as well. And I'll talk about board feet later if you don't know what those are. Other types of wood you might find are live edge pieces, which basically just have the raw edge of the tree still on one or both sides of it. More of a decorative thing. Popular for rustic designs, but you might end up planing or jointing and planing one side of it, but you might want to keep the edges live, so something to consider as well. Dimensional lumber is your 2x4s and your 4x4s that you get from Home Depot, usually made of softwood, and generally not used for like furniture projects and things like that, but useful as well. And depending on what you're doing, you might be able to use them without milling them if you don't care about a little bend in them, like if you're a framer. But if you do care about it, then you can mill pine as well. And then slabs, basically similar to live edge, but usually the term for when they come from a massive log. And again, usually they're going to be massive, so you can't really use the jointer, planer, table saw on them. Maybe table saw, who knows. But you're going to use your router jigs or your CNC to flatten those. Selecting quality, there's a lot of information on this slide, but when you go to the lumber store, you can either just walk in the front door and ask them for 40 board feet of walnut, and they'll just give you whatever they got. Or you can go into the back, into the warehouse, and select exactly which boards you want, which is what I always do, because you go there and half the boards you never want to touch anyway. So you want to select the ones that you actually want to use. Usually you want to just make sure they're straight. I look down the center line of it, make sure there's not like a huge bow. Again, everything's going to have a little bit of warp to it, so you want to just select the best ones you can find. Grain pattern, if that's important to you. Like I said earlier, rift sawn is going to be more structural. Plain sawn might have more aesthetic looks to it. Knots and defects can affect the structural aspects as well. And if there's knots in the wood, when you mill it, they might cause problems. If you go over a knot, it could tear out a bit more or something like that. And then, you want to make sure that there's not major cracks in the edges of your boards. The colors are consistent if that's important to you, if it's going to be showing, and things like that. Yeah?
If you end up with something that does have cracks, do you change it? Like, can you work with that, or?
If it's a major crack, if you end up with something that does have cracks, can you work with it? Like, can you still mill it, basically? If it's a major crack, if there's like a huge gash in the wood, I probably wouldn't try to mill it without first, trying to cut that section off if possible. If it's a minor crack, like if you go back, you might be able to see there's different kinds of cracks. There's checking, shake, and split. To be honest, I'm not super familiar with the differences in how it acts between those three, but sometimes I try to just mill over it if it's a small crack, and it can disappear if the crack isn't too big. But with cracked things, you definitely want to be more careful because it's already cracked. They have a tendency to crack more, and you don't want it to splinter while you're going through the jointer. So I would just, if it's too large, if you feel uncomfortable with it, I wouldn't try and mill it.
You can also fill it with resin.
Oh yeah, that's a good point. Yeah, he mentioned you could also fill it with resin. If you have a major crack, that's actually an aesthetic thing a lot of people look for. So they might find a big crack, fill it with resin to stabilize it, and then mill it after that.
And make sure that it's 3 days.
Yeah, good point. Make sure that it's cured for 3 days, before you use it on any of our tools, because they will ruin the blades and gum up everything. All right, next slide, board feet and pricing. If you don't know how lumber is generally sold compared to Home Depot where they sell it per board, at lumber stores when you're buying hardwoods they sell it per board foot, which despite feet in the name is not a measure of length, it's a measure of volume. A board foot is 144 cubic inches, which is basically 12 by 12 by 1 inch. So you can either try and calculate it yourself if you want. I'm not very good at it, so I usually just use an online calculator, but it's thickness times width times length in inches divided by 144. And so you can see in that picture, like all of those are 1 board feet, but they look a lot different, so you got to just be conscious of what you're purchasing. And the factors that affect price are going to be species, obviously. Walnut and oak are some expensive ones, and red oak is cheaper than white oak, things like that. And then, let me see, I have an example calculation here. It's kind of in depth, but I'll go through it quickly just to demonstrate how considering milling in your wood is important when you're designing a project. So for example, let's say you're making a walnut tabletop. You want it to be 72 inches by 40 inches and 1.5 inches thick. You got to consider that you can't use 6/4 lumber because that starts at 1.5 inches thick. And if it's already not flat, I mean, even if it's not flat, if you mill it at all, it's going to go under 1.5 inches thick. So you can't use that. You have to buy 8/4 inch. Most of the ones I find at Fine Lumber are 96 inches long. Some places will let you cut parts off of it and only take what you need. Usually that's when you cut, like, you leave like a good amount, 40% of it or more remaining, but some places don't let you do that at all, so you just got to know where you're going. You might need to buy extra wood and have waste there. If you want your boards to be the same width, you're either going to need 4 10-inch boards, 5 8-inch boards, or 6 6.5-inch boards or so. And you're going to lose some width on milling, so you need to make sure that you allow maybe a 1/2 inch to 1 inch wider, depending on how warped it is. So let's say we're going to buy 6 boards, 8/4 inch thickness, 96 inches long, that are 8.5 or so inches wide. I called Fine Lumber, and their 8/4 walnut is $13.41 per board foot. So if you do the calculation of 68 board feet, that's going to be $900 of walnut. Next, if you want to maybe think more about it, this is an idealized circumstance, but you might modify your design and say, oh, I don't need 1.5 inches thick. Maybe I only need 1 1/4. Now you can buy 6/4 inch, because as long as you don't get boards that are too warped, you can mill 6/4 down to 1 1/4. And yeah, you just got to be careful that you select boards with minimal warpage. You might find somewhere that has 80-inch boards instead of 96-inch boards, or that will let you cut and leave the others. Again, that, I don't know if you'll be able to find a place that has that, but let's just say you are. And then find boards with less crook in them, so you can get away with getting boards that are closer to your margin. You can get away with 7 1/4 inch boards instead of 8.5. And now if you did the calculations, instead of 60 board feet, you're getting 37, and it costs $500. So for basically the same table, it's 1/4 inch less thick, but it's close. You spend $400 less. It's just something to think about. Like, a lot of times you design with milling not in mind. You don't know what you're getting. You might end up wasting money. So yeah, some planning stuff, just some milling allowance is important. Like I said, you might lose up to 1/4 to 1/2 inch in milling, depending on the warpness. Could be more than that even. So ensure that each surface has 1/4 to 1/2 inch extra material. Ensure extra length for squaring ends. Like if you need a board that's, if you need 3 30-inch long boards, don't get one 90-inch long board and cut, because the saw is going to lose some material, and you might end up needing to square it later on after you get all other sides square. So you want some extra allowance. 10 to 20% is usually good, or 1/4 to 1/2 inch. Yeah, next slide. It kind of basically says the same thing, but 1/4 to a 1/2 inch per surface, 2 to 6 inches to rough length is usually what I go with. 4/4, once you mill it, you'll end up with 3/4 inch usually. 6/4 ends up with 1 1/4 inch, and 8/4 usually ends up with 1 3/4 inch. Briefly about shrinkage and wood movement. I'm not an expert in this, so you know, you might, if you're super concerned, if you're running into major problems with shrinkage and wood movement, you might need to look up more online. But essentially, radial growth is across the growth ring, so it kind of usually accounts for some expansion in the thickness of the wood. Tangential is with the growth rings, and longitudinal is along the grain. So, you know, width will increase, length will increase, and thickness will increase. Usually, thickness may change with the weather or with moisture content, like 4 or 5% thickness, and width will also be, it could be even more, like it could be up to 10% change in thickness throughout the seasons. Length doesn't really change too much, maybe 0.1 or 0.2%, but something to think about. If you're milling, you might want to, I don't know, include that in your planning. There's more to talk about there, but I'm going to skip past it because it's getting a little long. Oh yeah, feel free.
You mentioned reducing stress. Will you use your wood right after milling, or will you wait a bit?
That's a good question. I will, he asked, with the internal stresses and with maybe seasonal movement in the wood, will you use your wood right after milling, or will you wait a little bit and let it rest? I generally use it right after milling. It depends on what I'm doing. If I'm gluing up like a panel or a table or something, those stresses might warp it the next day. After like the new wood that's exposed to the air absorbs some moisture and stuff like that, it might warp it. But once you glue it up into a panel, it kind of holds it all together, and you know, the wood might sort of warp in contrasting ways and in essence keep it flat overall. So usually I like to mill and glue up as soon as possible. It's not always possible, so the next day you might just need to check, and maybe you need to mill it some more, maybe that board isn't useful anymore, things like that. But it is also useful to let the wood rest a little bit while you're milling it. So if you have to take off a bunch of thickness in the planer or something like that, if you just do it all at once, it has the potential to sort of stress it even more and cause more warpage. So if you let it rest for a minute or two or 5 minutes or up to a day or two, you might end up with a flatter board that resists movement overall rather than doing everything right at once. Yeah.
Removing a lot of material, do you take it off evenly on both sides?
He asked if you're removing a lot of material, do you take it off evenly on both sides? I would say yes, but you obviously want to get a flat face on the jointer first and then get a flat face on the other side first as well before you flip it over. So I would say like once you get 2 flat faces, I would start flipping it over in each pass if I needed to remove more. But again, I try to design my stuff so that I don't have to remove too much in the planer, because that can cause stresses and things like that. So if I was, you know, if I had a situation like that where I had to remove an inch of material, I might try and resaw it first. But yes, in general, if you do have to remove a lot, flipping it is a good idea so you don't stress one side more than the other and it ends up bowing that way. So tips and tricks, we're getting to the end here. So proper wood acclimation is good, as was mentioned earlier. So if you buy wood from the lumber store, your shop may have a different environment in terms of moisture content and things like that, and it might warp pretty quickly as it acclimates to that moisture. So if you buy it and let it acclimate first before milling it, then you might end up with more success afterwards, rather than if you buy it and mill it immediately and let it acclimate after that, then it might warp more. So, you know, as it changes environments, it changes wood, so let it change before you mill rather than letting it change after you mill. Batching steps is useful, so if I have like 10 boards, usually I try and joint the face of each of them one at a time before I move on to the next step of jointing the edges of each of them one at a time. That's just more for efficiency than anything. You don't have to change your setups or anything like that. Especially on the planer, it's hard to get like the thickness to be exactly the same each time. So if you're gluing up a panel, it's best to do that final pass at least at the exact same settings so they all match up. It also allows your wood to rest if you do one board and then move on to the next and wait until you move on. Cut to rough size first. I mentioned this earlier, but if you have a board bowed like in that picture, you're going to end up with 3/4 inches less of thickness once you plane it because there's a 3/4 inch bow in it. But if you cut it into thirds first, you're going to end up with a 1/4 inch less because each of them is only bowed a 1/4 inch. So you end up with more material and it's easier to work with. In-feed, out-feed rollers I talked about earlier help support your material for long material specifically. Sharp tools and small cuts are useful. I mean, the smaller the cut, the better, to be honest. It's less efficient. It's more time consuming if you have smaller cuts, but you're usually going to end up with better results with smaller cuts. And sharp tools, if you find that there's sometimes in the jointer or the planer, if there's a tooth in one of the blades that's chipped or something or dull, you might end up with like a line through it a little bit where you just see that. So if you ever run into that on the jointer or the planer, you might be able to move it to sort of avoid that area if it's causing a line. But that usually is caused because a tooth is either not sharp or it's chipped. So you might want to point that out in a problem report and someone will come and fix that tooth. Yeah, and then just think about efficiency. Your order of operations is the general workflow. And then grain direction considerations. If you talk to the next slide, you can see some pictures that help demonstrate what I was talking about earlier. It can be a little difficult to determine for some boards, but you might be able to see, again, in this board, I don't know where I put that chalk, but here it is. The grain in this board, you can see lines that kind of go up like this. And I was having trouble demonstrating it earlier, but if you look at that bottom right picture, you can see the saw is sort of chipping away along those grain lines rather than going into them the same direction. And the bottom one tends to cause more tear out. So you want, if possible, you want your grain to be facing that way. It's not always possible depending on the warpage of the wood and things like that. And you might just need to get flat faces first and then you can joint it the other way to reduce that tear out. And the planer is going to be the same conceptual direction, but it's feeding from the top instead. So it's going to be up and back instead of down and back, which you can see on the bottom. There you can see on the bottom right picture, the knives are moving along with the grain as well. So that's going to reduce your tear out if you have any. But you know, it's not something I always consider, to be honest. You might just mill, and if it has super major tear out, then you consider it afterwards. You test different materials out and things like that. And that's all I got for you. So hope you learned something. If you have any questions, feel free. No one? All right. Yeah, go ahead.
If you get tear out, what are some ways to mitigate?
He asked if you do get tear out, what are some ways to mitigate it later? I mean, if you have super major tear out, it's hard to avoid. You can sand it out if it's small. If it's major tear out, you might try to fill it in if it's not a visible surface. Generally, I'll try and remill it if it's possible, because I'm not aware of too many ways to just like fill in tear out. If you have something like this, like a cutting board, again, not recommended through the planer, but if you were to do something like this is tear out on the edges too. So you might make it oversized and then you can cross cut it later just to cut that off. So yeah. Yeah, go ahead.
I guess going into the planer, I already done the joiner.
Here, I'll give you the mic.
Yeah, you can hear too.
Yeah, so I had a question on the planer. I would be putting in the board, and about 4 to 6 inches are like slightly like, it looks like it's lower at the beginning of the board. Yeah, and like I asked different people in the shop, and everyone gave me a different answer. Is it the machine or is it a technique thing? Like it needs adjusted, or it's that part where it's coming in until it reaches the other roller?
Yeah, he asked about, it's called snipe, when you have the beginning or the end section of the wood can have like a little bit of a deeper cut that causes inconsistency in the material. And the reason that happens, I think, is because while it's feeding through the planer, it can even happen in the jointer too, but it engages one roller before the other and it might sort of like rock it down a little bit or rock it up a little bit. You know, it happens often, and usually not entirely the machine's fault. It can be avoided, and technique can help, but it's tough to fully avoid. So what I would just recommend is ensuring, like if it's a longboard especially, ensuring it's supported on the other end. If it's like this, you feed it through, sometimes you can kind of tell it's grabbing it, so just holding it to the bed, just making sure it's flat on the bed. And then it's useful also just to have that excess safety factor in the front and the end, so you can just chop it off afterwards. Like you can even see, it's obviously going to be really tough to see, but there's a little bit of snipe in this board. It's honestly hard to feel, but you can kind of see a little difference that probably would be sanded away. So, you know, again, I'm not the expert about that. Yeah, go ahead.
And then I guess the other question is dimensioning the wood.
Yeah.
So like you've milled it, how do you get it to 2 inches thick the whole way? Like do you finish it on the belt sander, or what's the recommendation?
Yeah, so your question was if
Like
you...
dimension. So like getting it, I need it to be 2 inches thick.
Yeah. I mean, I generally just sneak up on my final measurement in the planer. You can do it on the belt sander if it needs to be super accurate and you don't want to lose any tiny bits of extra width when you sand it by hand or with a rotary sander. But if I'm shooting for 3/4 inch for something, I'll just do that on the belt sander. I might get calipers out and basically do it. It says it's 0.77 and you try and just barely turn that wheel, sneak up on it. If it's something to just practice with and to try out. If you find that you have tear out, maybe you don't want to do that. You want to leave a little bit of excess and then finish it on the belt sander. So kind of changes project by project depending on the wood you're using and your final requirements. A lot of times I'm making something, it doesn't really matter if it's 0.75 or 0.74. So.
It's like if all your boards are the same thickness.
Yeah. If I'm making a tabletop, all I care about is that they're the same thickness, not that they're exactly the right thickness. But it depends on your requirements. Do you have a question?
Yeah. What's a good wood to practice on? So I'm not spending money on maple or something like that, and then just
that's a good question.
Mess it up.
He asked what's a good wood to practice on. I mean, really anything. Pine is fine if you just want to practice your milling. Things like cedar, it can be cheap. Softwoods are generally cheaper. As far as hardwoods go, there are some cheap options. I think cherry is $4 or $5 a board. I could be wrong about that. And Purple Heart's generally pretty cheap. I think. I don't have the prices super. I'm pretty sure it's
Cherries,
Yeah, cherry's a good one.
Yeah, also I saw a few people over here pointing at our scrap carts, so that's
Oh,
a
yeah.
really good option too if you're interested
Very good
in
one, too.
not wasting your money and material, just grab scrap from the cart first.
Yeah, good point. Yeah, if you just want to practice on scrap, feel free to grab some there. But if you want to practice on boards, pine, cherry, I don't know. Ask Fine Lumber what their cheapest hardwood is. They probably have some for $3 or $4 a board foot. Go ahead.
I was going to say one more answer to your question for both of them is grab a scrap piece, because usually the snipe is where the rollers drop in the back, like Adam was saying. Use your dimensional, that's how you get down to your final dimension on that. But also you do the piece after your nice piece, it keeps it from dropping into that snipe on the edge if you kind of force a sacrificial board through the back afterwards as well. So it's butting up against it and pushing it through. You do it the whole way, so as he's talking through the multiple steps, you do it each one as you're down. That way you also can use it to kind of get down to your final dimension with your scrap pieces as well, with a pair of calipers, and then you can figure out if you're close.
Awesome.
Cool.
Do we have any more questions from anyone else? All right, I think I have one to wrap it up. What is your favorite wood to work with here at Asmbly?
My favorite wood to work with is probably walnut. I don't know if you remember seeing my projects earlier, but I just really like working with walnut. I like how it looks, as most people do. And I would probably consider it the most popular wood in woodworking. It is very expensive, but it's fun to work with. It's super smooth and easy. It generally doesn't burn in the saw or anything like that. And I just love how it looks in the dark color. But, I really like oak as well. Another expensive one. I guess I have expensive taste in wood. But oak is fun to work with. Oak tends to splinter a little bit more and tear out along the edges a little bit more, so it's definitely a little tougher than walnut, but it's fun as well. That's probably, I've used some cherry and some mahogany as well, but most of my projects are either oak or walnut. Yeah, anything else?
All right, awesome. Thank you so much, guys. Let's go ahead and give a round of applause for Adam.
Thank you.
Thank you, Adam. That was super awesome. Great demonstration on milling wood, and we really appreciate it. Thank you, Asmbly, for hosting us and for putting on this event. And just a little plug for the next event is our Maker Showcase, and that'll be Saturday, October 19th at noon. And we're still taking applications if anybody has an interesting project they want to present there. So thank you so much, Adam.
Thank you.